All right, so this is for question 1A. Question 1A, they ask you how to show that it is a right angle triangle or explain that it is a right angle triangle. Please remember to show all this working. Okay? All right. So you start off with the short square plus the medium square. All right, and you end off with the longer square here. And this statement must write, please. This statement, by converse of Pythagoras theorem, means like the knowledge of Pythagoras theorem you have. All right, this portion, right, makes it a right angle triangle, and therefore your angle PQR is 90. This is your explanation. Cool? All right, with this knowledge, you have proven that it is a right angle triangle already. You can actually go on to the next question. Here they say that QR is produced to S. QR is this length here. Can you see the white color line? Produce means it's extended out. If they use the word produce, right, extended out, it means that it is a straight line. It will be a straight line. Such that RS down here is a 5 cm. You're supposed to find the area of PRS. You're supposed to find the area of the green color one. Yes, Doreen, you participated and you say the answer is 60 cm squared, correct? All right, how do you find the area of the green triangle? This is what I call a slanted triangle. All right, so it's actually half times base times height. This is the base, and where is the height? All right, some of you do not have the idea where's the height. The height is you have to reach the top portion here. This is called like the vertex of the triangle, the highest point. All right, you have to extend downwards to form a perpendicular line with the base, to form a 90 degrees with the base. And this portion is what we call the height. All right. So understand how to find the area of a triangle. Half times base times height. The height is the perpendicular height. You must know this. All right. Learn to extend out the line. And the height here is a 24 cm. And the base we know, question says is a 5 cm. So you can apply into your formula of area of triangle is half times base times height. Usually for me, I like to write out the formula so that my fingers can actually do the remembering of the formulas. All right, times 24. Half times 5, yeah, very hard to times. So I purposely take half times 24 first. Half times 24 will give me a 12. 12 times 5 will give me a 60. 60 what? Units must write cm square. And this is your answer. All right, this is your answer. Right? Hopefully that this one is easy. So first part, right, the 1A, we did something called proving of a right angle triangle. Second part, we do something called what? Finding the area of triangle. All these are simple questions. All right, but remember the proving of the triangle, right angle triangle, the format must be there. Okay, the presentation must be there. Let's move on to question 2. Here, we are talking about something called TOA CAH SOH and Pythagoras Theorem also. Everything that is right angle triangle, you have to talk about that. So here, they are looking for angle QTR. QTR here is 90. Got it. RST here is also 90. Got it. RQ is produced to P. Can you see now? RQ here is produced, means it's a straight line. Okay. And RT is 5 cm, good. RS is 4 cm, ST is 3 cm, and QR is 13 cm. Always look at the paragraph and look at the diagram. Make sure they are in line. You're supposed to write down sine STR already. All right. So where is sine STR? What must you do? My first thing I will do is I will activate my spelling of TOA CAH SOH. Because I see a right angle triangle, I get excited. I write out TOA CAH SOH first. And sine. Sine is talking about this formula here. What is the secret formula here? All right. It's actually sine followed by an angle. We call it theta. Is equal to O. O is the opposite, and H is the hypotenuse. All right, so usually I'll write out the general formula first. This is the general formula for sine theta in a right angle triangle. So how? Where is the focus? The question is looking for STR. STR is this blue triangle here. All right, so this blue triangle is drawn like that. Okay, let me just extract it out. STR. All right, so you must determine which angle are we focusing on. Which angle are we talking about? Talking about STR. So we are talking about angle STR, this angle. We are talking about this angle over here. Okay, so this angle is the one on focus. We call this theta. Where is the opposite? Opposite is the one directly opposite the angle, which is down here. All right, so this one we call it opposite. Where is the hypo? Hypo is the longest, which is opposite the 90. All right, and where's the adjacent? This is called the odd one out. So once you have this in mind, everything you just got to substitute the numbers in. We have the adjacent as 3 cm, we have the opposite as 4 cm, and we have the hypo as 5 cm. All right, from this portion of the diagram here. Can you see? So now the formula is what? Sine theta, this is the general formula, is equal to opposite over hypo. I'm just copying down. And now I try to substitute in the correct numbers. Theta, right? We are not looking for a general theta. We are looking for angle STR. So I can put in STR like that. And what's the opposite? Opposite is actually RS, the length RS, and the hypo is RT. Can you see? All right, so opposite over hypo. And I can give a final conclusion. Sine angle STR is equal to RS. What is RS? RS is 4 and RT is 5. All right, so your answer is simply 4 over 5. Hey, Che, can I bring the sign across? Some of you say, I want to find what? I want to find the angle. I want to find STR. All right, the angle itself. So the sine, right, can I bring across? I bring across to give me sine inverse 4 over 5. And you press your calculator. All right, you press shift sign, 4 over 5. That will give you what? 53.13010 degree. Then you say, give it to 1 decimal place. 53.1. All right, this is 1 decimal place. And is that the answer? No. All right, that is not the answer. How come? Because the question only specifically asks you to what? Only asks you to find what is sine STR. All right, the question only specifically asks you to find what is sine STR. Question never asks you to find what is angle STR. So you have to answer the question properly. All right, answer the question properly. So in this case, right, your only answer is here. All right, in yellow. This is your only answer. All right, so you give your answer as a fraction. It is correct. Don't worry about it. Don't go and find the angle. Don't go and do extra one unless the question asks you to. Okay? All right, so moving on. This is using TOA CAH SOH already. You're supposed to find tangent QRT. Again, once again, when you see tangent and all this, right, I will spell out TOA CAH SOH. As you can see, right, the way I do things, right, is very systematic one. All right, tangent, right, means you have to look at TOA lah. What is the hidden formula for TOA? Tangent theta is equal to O represents opposite, A represents adjacent. That is the general formula for TOA. All right. So at this moment, where is QRT? QRT, we are talking about this yellow triangle down here. All right, this yellow triangle down here. Okay, let me just go and extract it out. So you have something like that. Okay, down here is your 90. This is Q. This is R. And this T. And this is your P. All right, question is looking for angle QRT. QRT is where? The focus angle is here. This is the angle you're looking at. So if that is the angle, where is the opposite? All right, if this is theta, this one is called the opposite here. The longest is always opposite the 90 degrees, and the odd one out is called the adjacent. Can you see? Okay, so now what do we have? Do we have the numbers here? What is hypo? Hypo is 13 cm, question did say. All right, what is RT? RT, the adjacent here is 5 cm, good. But I'm short of the opposite, then how? Fine lah, don't have, go and find. All right, so what do? Okay, I can say that RT square plus the QT square should give you the RQ square. Why? This is something called Pythagoras Theorem. All right, so it's the short square plus the medium give you the super long square. So RT square is equal to what? RT square is equal to 5 square plus QT. I don't know what is QT square. I want to find. RQ is 13 square. Can you see? All right, so QT square will be simply equal to 13 square. The plus 5 square you bring across is a minus 5 square. And you can continue saying that QT square is equal to 169. 13 square is 169 minus 5 squared is 25. It's a 144. Then what's QT? Be careful, be careful. Square root of 144 is not only a 12, but a plus minus 12. You have to know this. All right. Then you give a final conclusion. Therefore, QT is equal to 12 cm, and you reject the negative 12. Can you see that? All right. So QT is a 12 cm. Okay. So that's how I use Pythagoras theorem to find the answer. The presentation must be very clear. Okay. So down here, what they want? Okay. Let's talk about the question. Question is talking about tangent. Okay. Tangent. Who? The angle at focus here is QRT. Okay. Opposite over adjacent. What is the opposite? The opposite is your QT over your adjacent, which is your RT. And guess what? Do you have both the numbers? You have. All right. So QT is, you just found, is 12. RT is a 5. And this will be your answer. All right. 12 over 5. Usually for this situation, right, I will just present it as an improper fraction. It looks nicer. All right. It looks nicer. So I will just write it as 12 over 5. All right. So the question is looking for tangent QRT. I give the answer tangent QRT as 12 over 5. This is the correct answer. All right, so it's okay to write as an improper fraction. Don't worry. Because if you change it to a mixed number, it's a little bit ugly. 2 whole and 2 over 5. Ugh. All right, so that is how I'll present. Okay, so this is all within the right angle triangle. We call this acute. Now there's another question here where we talk about the outside. Cosine PQT. Once again, you're looking for cosine, right? Okay, so I write out my TOA CAH SOH first. All right. And because they are talking about cosine, my focus is on this secret formula here. Cosine theta is equal to A adjacent over H hypo. All right. So this is the general formula for cosine. So what do you do now? The focus is what? PQT. We are talking about the yellow part of the triangle, right? Okay. So let me just draw out again. So this portion is like that. Okay, like that. Then like that. Okay, down here is your 90. And down here is your R, Q, P. And here is your T. We have this as 5 cm. We have this as 13 cm. And just now we found QT, right? QT is what? QT is 12 cm. Down here is 12 cm. So we've got so much information already. However, the question is talking about what? The question is talking about cosine PQT, which means the outside. Like, can you see now? This is called the outside. Or we call this the obtuse. Or I call this the outside. Where's the inside? The inside is, inside here, the shaded yellow. Right, this is what I call the inside. So the inside is a acute angle. Can you see or not? Inside means inside the right angle triangle. Outside means outside. Remember, your inside and outside must form the what? Must form the 180 degrees. Very important. It's a straight line. That's why the keyword down here, they say that RQ is produced to P. Means that it's a what? It's a straight line. All right. So usually when I say inside means inside the right angle triangle, outside means the one that is outside, which is the obtuse angle. So remember about this inside and outside. All right. So I drew the table out just now for you. Remember this table here? Okay. This table, if you can use it, is quite useful. Okay. For sine, cosine, and tangent, we have the acute versus the obtuse here. For sine is always a positive. Cosine inside is also positive. Tangent inside is positive. Cosine tangent outside is a negative. Okay. So what happens here? The question is looking for cosine outside. So usually in my head, right, I'll be thinking this cosine outside is equal to the negative of cosine inside. All right, so this is my thinking. This is inside my head. I always thinking about this. All right, because outside and inside, right, there's a relationship. Okay, so cosine outside, right? We are talking about cosine here. Cosine outside is a negative. Negative of what? Cosine inside. All right, so if you have this idea in mind, right, because the question is looking for cosine outside, they're looking for angle PQT. So I can say that cosine angle PQT, PQT is outside, right? Is actually equal to the what? The negative of the cosine inside. Cosine inside is what? Cosine inside is RQT. angle RQT, which is the acute angle, which is the shaded one. Can you see now? So that's how they are related. That's how they are related. Cosine outside is the negative of the cosine inside. So the question is looking for cosine PQT. All right. Cosine PQT is the minus of the cosine of RQT. So how? I need to go and find what is RQT first. Okay. So cosine RQT, you can do a side working here. All right. Cosine is equal to what? Adjacent over hypo what? Adjacent over hypo. All right. So if this is the angle inside, we call this the opposite. We call this the hypo, and we call this the adjacent. Okay. So the angle at focus is angle RQT. All right. Opposite will be the 5. Hypo will be the 13, and adjacent will be your 12. So cosine RQT is adjacent over hypo. Adjacent is what? Adjacent is given as QT over hypo is RQ. So if you can put in the numbers, QT is a 12, RQ is a 13. So this is called cosine inside. All right, cosine inside. So why do you need this portion? Why do you need this portion? Because I need to put it into here. All right, so the negative is still there. Cosine RQT is 12 over 13. No? So that's your answer. Okay, so the question is looking for cosine PQT is simply equal to negative 12 over 13. Okay, so remember that they are related. The acute and the obtuse are related. The only difference for cosine and tangent is there's this negative sign. For the sine is both positive, very safe. All right, so this one, please, you need to know also for the Sec 2. All right, Sec 3, you must know even more. All right, so this one is your trigo. It's just a revision from your Sec 2 work, just to let you know. You have learned this in Sec 2. Okay, now we move on to question 3. What do you have? So down here in the diagram, ABC is a straight line. So we know that it's a straight line already. So what? AB is 12 cm, okay? BD is 10 cm. Oh, then they give you this clue. Sine DBA is 4 over 5. When I see sine DBA like that, right, and I see a fraction, right, I'll remember TOA CAH SOH. TOA CAH SOH. And when we talk about sine, right, sine, the general formula is sine theta is equal to opposite over hypo. Okay, so down here, what do we have? DBA, where's DBA? DBA is talking about the blue triangle, you know, which is down here. Can you see the shaded red color? This is outside, you know. Oh, outside and inside. Right. Outside and inside this right angle triangle, this yellow color triangle got relationship. Right. Because they form the 180 degrees straight line. So outside and inside got relationship. So I need to go and find I need to find more information about my yellow triangle first, because it's easier to work with a right angle triangle. So how? Even though they give me the sine outside, I know that there's a relationship to the sine inside. So I will tell myself, all right, I will tell myself in my head, sine outside is the same as sine inside. This is only for sine. All right, this is only for sine. Remember just now? Cosine outside is the minus of cosine inside. But down here, sine outside and sine inside, same. Don't worry. All right, so with this knowledge, right, I can tell myself that sine outside, which is sine angle DBA, all right, this is outside, is equal to the sine of inside, angle DBC. All right, so the shaded angle and the not shaded angle, they are the same, all right, for sine. So sine outside is equal to sine inside, which is equal to what? Which is equal to 4 over 5, all right? Sine outside is 4 over 5 what? Which means that sine inside DBC is also 4 over 5. So now I focus on this right angle triangle, this yellow triangle. Okay, this is your DBC. Okay, and I know that sine, right? Sine is what? Sine angle DBC is supposed to be opposite over hypo using the general formula. And if DBC is this angle here, where's the opposite? Opposite will be your DC. Hypo will be your DB. And the odd one out adjacent will be your CB. Can you see? All right. So sine DBC is DC over DB, which is equal to what? Do I know? Do I have the length of DB? All right. DB is what? 10 cm here. Okay. All right. But DC, I don't know. Don't worry. All right. So from above here, down here, sine DBC is equal to 4/5. I can say that sine DBC is 4/5 also, because it's the same thing. DC, I don't know. I don't know. But the actual length of DB is a what? Actual length of DB is a 10 cm. All right. Actual length of DB is a 10 cm. So I purposely put 10 cm down here with the units safer. 4/5 is just a ratio. It's a comparison. 4:5. But the 10 cm is the actual length. Can we go and find the actual length for DC? So down here, single fraction equals single fraction. Let me do a cross multiplication. 5 times DC is 5 DC. 4 times 10 is a 40 cm. How do you find DC alone? DC is 40 divided by 5 is a 8 centimeter. Can you see now? That's how I find DC for this question. All right, so sometimes they just give you a fraction. You are supposed to learn how to extract, how to link, and eventually get to the final answer. Can see? All right, so with one ratio or one fraction, you're supposed to compare with the actual length. Once you got one side as the actual length, you can easily compare them. All right, so DC will be your 8 centimeter. Okay, moving on. What is the value of angle ABD? Where's ABD? Oh, ABD is the outside angle here, the shaded outside. All right, but don't worry yet. We have the yellow triangle. All right, this is called DCB. We need that. This is your 90. This is your 10 cm. And just now, what did we find? We found that DC is 8 cm. DC is 8 cm. Can I purposely go and find what is CB? Can, using Pythagoras Theorem, just for fun. All right, so I can say that DC squared plus CB squared should give me the longest DB squared. And this is called Pythagoras Theorem. All right, so if you're using his theory, can you please declare his name? All right, so DC is 8 square plus CB. You want to find CB? All right, it's equal to DB, which is a 10 square. CB square is equal to 10 square is here. Here is a plus, you bring across is a minus 8 square. And your CB square will be equal to, you press your calculator, 100 minus 64, that will give you a 36. Be careful again. Be very careful. I say this my third time already. CB is equal to the square root of 36, which is equal to what? Plus and minus 6 centimeter. All right. However, you can only accept the positive. Then you have to say that I reject the negative 6. All right. cm, rejected. The teacher will not ask you why. All right. But if the teacher asks you, then you just say that a length cannot be negative. So that's how you present your Pythagoras theorem. CB being 6 centimeter. Okay. So once you get that, okay already, okay already. All right. What is the relationship between inside and outside? Because outside is this angle here. All right. Question is looking for this outside, this portion. This outside shaded is related to the inside here. So remember cosine. So I told you, right, cosine outside. This is your thinking process. Cosine outside is equal to the negative of cosine inside. Okay, so cosine outside is talking about what? Cosine angle ABD. Right, ABD is outside what? It's equal to the negative of cosine inside. Who is the inside here? All right, we call this what? All right, we call this DBC. Cosine angle DBC. All right, so the outside is the obtuse angle, the inside is the acute angle. So cosine outside ABD is equal to the negative of cosine inside DBC. So you need to go and find what is angle DBC first. All right, your minus sign is still here. All right, what is cosine DBC? That's the question. Okay, so let's take a look at cosine DBC. Cosine, I know I have to use what? The general formula again. Under CAH. All right, so down here, CAH is cosine theta is equal to adjacent over hypo. All right, so let me go and find the cosine inside first. Cosine DBC is equal to, this one is called the opposite. This is called the hypo, and this is called the adjacent. Cosine is adjacent over hypo. Adjacent is your CB against your hypo, which is your DB. So if you want to present, you can present cosine DBC is equal to CB is a 6, DB is a 10. Reduce to lowest term is 3 over 5. All right, always try to reduce to the simplest form as best as you can. So the entire cosine DBC is equal to 3 over 5. So I put it here as 3 over 5. And that is your answer. That is your answer. That's all. Okay, don't think too much. All right, once again, using the outside, cosine outside is the same as the negative cosine inside. All right, always think this to yourself. Very, very useful. All right, moving on a little bit more. What do you have? Here, you want to find the area of triangle DBA. Where's the area of triangle DBA? Here, the blue triangle. Easy, easy. All right, once again, this is a slanted triangle. So you have something like that. This is the base, 12. Please, you must know where is the height. Where is the perpendicular height? Perpendicular height coming down from the vertex, the highest. All right, link up with your straight line here. This is the 90. What is the height here? All right, you look back at the previous. We found that it's actually 8 cm already. Can you see not? So 8 cm is found from here, part A. This is very scary. How come? If your part A is wrong, your part B will be affected and your part C will also be affected. Can you see? All right, so that is the scary part in elementary mathematics because they are all linked up. If your A is wrong, the rest will be also easily affected. But you say that, sure, got some method marks here and there. Yes, but method marks is not strong enough to get the full marks. All right, you want to be as accurate as possible to secure all the marks as best as you can. All right, so everywhere you make some small mistake, I tell you, it's not worth doing in a way. You want to do it correctly one time and the first time. All right, so be very careful. So area of this triangle will be simply half times base times height. All right, usually, once again, I like to write out my formula. And half times base is a 12, height is a 8. Half times 12 is a 6, 6 times 8 is a 48 cm square. And this will be your answer. All right, this is still considered quite simple. Nothing to worry about. All right, 2 more questions. Let's go to question 4. All right, bear with me. Oh, this one very, very important also. This one is something like your O-level kind of question. Usually it comes out one. So sine of an angle is 0.86603. So I'm going to use this English, right, to translate to what? Mathematics. They say sine lah. Angle means theta. Is means equal. All right, is means equal. Angle, I just say theta. Sine means sin. All right, so sine theta is equal to 0.86603. Question say, I want to find 2 values in degrees for the angle. Means that the question wants to find theta alone. So how? Easy what? The sine bring across lah. So this sine, if you want to bring across to the opposite side, right, you must take sine inverse or sine to the power of -1. And your 0.86603. What do you do? Key into your calculator. Shift sine, all right, shift sine 0.86603. And your answer should be 60.000526. That's for theta. All right, for angles, usually we give it to 1 dp. So theta is approximately 60.0 degrees, 1 dp. All right, so this is how you declare. Hey, sure, there's only one answer. Really? Remember me telling you about the sine inside and outside? Yes. How are they related? Sine inside and outside, they are related by the 180 degrees. All right, sine inside and outside is related by the 180 degrees. So 60 is considered the acute angle. How do you find the other answer? The other answer is actually your obtuse angle. So theta can be, you must take 180 degrees minus the 60.0000526 degree. All right, and your answer will be 180 minus the answer in my calculator is a 119.999. All right, 1 dp, all right, is 120.0 degrees, 1 dp. All right, because the 9 cannot round up already, what? So you'll push everything up to 119 becomes 120.0. The 0.0 must right. All right. So when they ask for two answers, these are the two answers. All right. So remember just now what did I say? The acute and the obtuse angle, right? They must add up to the 180 degrees one. So usually for sine, right, they will ask you for two answers, and you must give two answers. How? All right. One is to simply just bring your sine across, shift sine, you get the 60. The second answer, simply just take the 180 to minus. Very, very common kind of question. Must know this. All right. I've seen this coming out in the O levels, I think twice already. Okay. So, there's something else called radian. All right. For the Sec 3, radian is something new to you. All right. For now, just help me change in your calculator. All right. How do you change in your calculator if you're using the Casio, right? Press Shift Manual. All right. If you're using this Casio, this new one, FX97 SGX, press Shift Manual. Look at number 2. It says angle unit. Press number 2. Then they will ask you number 1, degree, number 2, radian. Press number 2. Change your calculator to radian. All right. If you are using the older version of Casio, FX96 SGX, oh no, it's not working. All right. My one got no battery already. All right. So I cannot help you down here. I'm sorry. All right. But you can play around. I think you have to press Shift Mode also. All right. Press Shift Mode and look for the word radian. R-A-D. For those using a sharp calculator, right, you can simply press, let me see. Where's the radian? Okay, you can, I've forgotten already. Okay, I think it's down here. Second function, this. Okay, good. All right, for those who are using a sharp calculator, you can press the second function and press the decimal, the dot below. All right, then they'll ask you radian, you press equal. All right, then how do you change back? You press second function, the decimal dot. They will give you to gradient, the 1. Then you press again, second function, decimal dot, press equal. All right, then you will go back to degree mode already. All right, second function, decimal. Yeah, so it goes back to something called degree mode. For those using the Casio, right, how to go back to degree mode, you can press Shift Manual, press number 2, angle unit, press number 1, degree mode again. All right, but this question is talking about something called radian. So how? We need to change your calculator to something called radian mode. So Casio, Shift Manual, angle unit, press 2, press radian, press 2. Okay, so now your calculator is in radian mode. On top, you can see a small r. The small r means that it is in radian mode. Okay, so once again, what do they want? The question is asking for what? The question is asking for sine x is equal to square root 3 over 2. The question wants you to find x. And they also want you to find two values of x. Don't panic. Let's go and find one first. How do you bring the sine across? Right, sine you bring across will give you a what? Shift sine, or sine to the power of -1. Square root 3 over 2, you can put it back. Square root 3 over 2 like that. All right, then you have to press your calculator. All right, press with me. Shift sine, press the fraction key. Square root 3 is on top. Press the down button. Press the 2. Close the entire bracket. You should get a 1.0471975. In radian, right, we always give it to 3 significant figure. 1.05. All right, the unit is called radian, and you declare it as 3 significant figure. So this is considered one answer. All right, this is considered one answer. So in future, you'll be learning that angles, right, can be used something called degree and something called radian to help you get the answer. All right, radian and degree. So on the left-hand side is the degree, on the right-hand side is the radian. So you have to be very clear. And again, what happened? You are supposed to find the other answer. The degree one is easy. Simply take 180 degrees to minus. But in terms of your radian, what is the 180? That is a very important conversion out here. Remember this for me, please. Pi radian, all right, pi radian is equal to 180 degrees. This is like the conversion between radian and degree. All right, remember this for me. All right, because your next topic I think will be covering something called radian already. All right, so pi radian is equal to 180 degrees. Okay, so if pi radian is equal to 180 degrees, all right, how do you find the second answer? For degree, as I say, it's easy. Just take 180 degrees minus the previous answer. Now what you do? pi radian is equal to 180. Simply just take your pi radian, which represents 180 degrees, minus away your previous answer, which is your acute answer, 1.047197.5 radian. And can you see, every time I minus, right, I will try to use the what? The more decimal one. How come? Because I want to make sure that my answer accuracy is there. All right, so you simply take your calculator's pi minus the previous answer. You should get a 2.094395 radian. All right, radian always give to 3 significant figure. Angles only give to 1 dp. So this one is radian, the units, and you declare it as 3 significant figure, like that. All right, so remember that at the end of the day, use your calculator, change back to degree mode, please. Shift manual, angle unit, change back to degree mode. All right, always keep it in degree. If you need to use in radian, like this type of question, then you change to radian. If not, always keep it to degree mode. All right, so this type of question must know how to answer. It's very simple, just pressing your calculator. And remember, in order to find the second answer, simply just take your 180 degrees to minus away. All right, and there's one more last question. All right, one more last question. Do bear with me. All right, this lesson is actually quite short. Okay, just one more question here. What do you have? Bugs Bunny. All right, do you see this diagram? Cute, right? So for instance, Bugs Bunny is 1.92 meter. 1.92 meter is this entire height, for example. Right, down here is 1.92 meter. Okay, he stands on the horizontal ground, 60 meter from the flagpole. So from here to here is 60 meter. The angle of elevation of the top, this is the top of the flagpole, from his eyes is 36. All right, so the eyes is down here. The eyes is down here looking up. Okay, so where is the angle of elevation? Okay, angle of elevation means you look up. All right, because there's some height involved down here. So where is something called, we need to have something called the horizontal, the imaginary line, which is actually parallel to the, which is actually parallel to the ground. So there is this horizontal line, all right, from the eyes, that's actually parallel to the ground. All right, so this portion actually forms the 90 degrees. So when we talk about angle of elevation means looking up. So the bunny looks up to the top of the flagpole. This will be a 36 degree. That's the meaning of angle of elevation. All right. And guess what? All right. If they are 60 meter apart, can I say that this yellow line is also 60 meter apart? Can I purposely go and find this green portion first? Here. Can I purposely go and find this green portion first? Can. How come? Because it's a right angle triangle, right? So if 36 is the angle, this is called the opposite. The longest is called the hypo, and the odd one out is called the adjacent. If it's a right angle triangle, I can activate TOA CAH SOH or Pythagoras Theorem. So let me write out my TOA CAH SOH at the top portion here first. TOA CAH SOH. Okay. So question, right, asked for the height of the flagpole, the entire height of the flagpole. So if I can find opposite, that will lead me closer. Okay. So I need opposite, I have adjacent. I need opposite, I have adjacent. All right. So which formula will have opposite and adjacent inside is actually your TOA. So TOA angles or tangent theta is equal to what? TOA opposite over adjacent. This is like the general formula for TOA. Okay. So which angle are we talking about? We are talking about the 36 degree. That is the angle at focus. What is the opposite? The opposite, right? We can call it opposite here. And the adjacent, what is the adjacent? Adjacent is the, here, 60 meter. Very good. This tangent 36, right? Can I write it as over 1? I purposely make it into a single fraction so that I can do a cross multiplication. Single fraction equals single fraction, cross multiply. Opposite times 1 will give you an opposite. All right. 60 times tangent 36, 60 times tangent 36. What does that give me? Press your calculator. Remember, your calculator must be in degree. How come? Because this angle here is in degree. Can you see? So be careful. 60 times tangent 36. it will give you a 43.59. 43.59255. 168 meter. All right, that is this portion here. But not forgetting, right, the height of the what? The height of the bunny, all right, you have to bring it in also. So that's why the question asks you to find the estimated height. Can you see not? All right. So usually the bunny, right, or usually for humans, right, the eye and our height, right, down here, right, there's only a small gap that is difference only. All right. So when we talk about height, we talk about the top of our head, right? Yeah. All right. The eyes is here. So if you from eyes look up, right, there's this portion that is missing, this portion. All right. So that's why the question asks for the estimated height. So in a way, right, the question is trying to say that the height of the bunny, all right, and the eyes where the bunny is looking from is the same, which is 1.92. Can you see or not? The height of the bunny and the place that its eye is looking up is the same at 1.92. All right, that's why the question says it's the estimated height. Because yes, you can argue that this portion, right, is different one. All right, the bunny got longer ear, then you can say that also. All right, that's why they're asking for estimated. All right, so understand that this type of question, right, you have to take the entire height in play. Okay, so you simply go and find the height of the flagpole. Height flagpole is simply equal to your 43.59255.168 plus the height of the bunny, 1.92. All right, taking that his height and the eyes is at the same place, plus 1.92. And therefore, your answer is 45.51255. Three significant figure, 45.5 meter. Three significant figure. All right, that's what the question wants also. And in meter, you must write out the units. And that's how you present your answer. All right, this is something called angle of elevation. Okay, so today's lesson, right, we talk a little bit about how to prove a right angle triangle, which the format is very important. Learn to use the format, nothing will go wrong. All right, and also the wordings. All right, that is for question 1. And also taught you something called TOA CAH SOH. All right, how do you find the angle? How do you present it as a fraction? And also from the fraction, how do you extract out the information to find the actual length and all this? And also what? The acute and the obtuse angle, yeah? So the inside and the outside, how they related? Yes, we covered that also. Can? And we also talk a little bit about something called the angle of elevation. Right, so hopefully this lesson, right, this 5 questions will get you more interested in trigonometry, because trigonometry is a very huge topic. When you are in your secondary 4 O levels, right, trigo can easily reach about 20 to 30 marks. Yes, for the entire paper. Paper 1, paper 2. All right, so it's a must know. It's supposed to be your favorite topic. All right, so get to know your trigo very well. And again, if you need some additional practice, okay, if you are Sec 3, most of you are Sec 3 here, you can actually go and visit lesson 25, right, inside the 88 tuition, the package, all right. If you have a trial package with us, or you have the full package itself, that's good. Go on to lesson 25 and you can actually try out more questions down there. Cool. And also you can look at the if you've got some additional question, you can actually WhatsApp me at 8933-0213 for any math related question. All right. So that is all for this trigo lesson. All right, it's 1 hour only. It's okay. All right. So usually I'll put the time as 1 hour to 1.5 hours. If you got more questions to ask, all right, you can actually let me know so that we can discuss your question also. Cool. Okay. So just to let you guys know that we need at least 8 to 9 students to begin lessons. All right. Today's the number of students is, I think, only got Sydney, Vic, and Jeffrey, the 3 of you only. Right, the rest are actually I don't know. Doreen is Sec 1, so it's not really relevant to her, but she's actually listening. That's good, I think. All right, then there's another one, Bernice. I don't know who is this. I mean, somebody just came in, is it? I also don't know. So and Bernie O is actually me. All right, I have my own I need to see whether the part of the slides, is it relevant to what you're looking at. That's why I'm in here also. So I don't know whether will this lesson continue next week or not. Okay, but let's hope that we can continue with more students. Okay, if there is a lesson next week, it will be still on trigonometry. All right, it will be on the next portion of trigonometry where we talk about sine rule, cosine rule, and the area of triangle. Yeah. All right, so the right angle triangle is just like the first part. The second part is actually the more important and more formulas one. Okay. So once again, if you have friends who are in Sec 3 or Sec 4, all right, do ask them to come join the class if they can. Okay. All right, and that's all for this lesson. I hope that you have learned something from here. All right, and if you have any question, you can actually type into the group chat and I can answer. All right, and if you have any question, you can actually send me the picture. All right, then we can also discuss it if you want. Cool. If not, then there's nothing for me to you. All right, keep practicing and do stay at home and be safe. Okay. All right, and that's all for this lesson. In the meantime, do take care and see you the next week, I hope. Okay, bye-bye.